In this video, we'll be identifying the center and radius of a circle when our equation is in standard form. Recall that standard form of a circle is x minus h squared plus y minus k squared equals r squared, where our center is hk and our radius is r. So our first equation, x plus 1 squared plus y plus 3 squared equals 11, is definitely in standard form. And from here, we want to identify the center and the radius. You'll notice that our standard form has minuses in our equation. In this first example, there are not minuses in the equation. So we can force the minus by rewriting this x minus a negative 1 squared plus y minus a negative 3 squared equals 11. Now that we are in standard form with the minus sign, we just take a look at the number after the minus sign, and those will give us the coordinates for our center. We get the center to be negative 1, negative 3. Now, if you just take a look at the original equation, you'll notice that the signs for the center are just the opposite sign that was listed in the equation. So typically, I don't do that intermediate step. I just take the opposite sign of whatever I see inside the parentheses. So that takes care of the center. The radius is always the square root of the constant. So that will be the square root of 11. We look to simplify the radical. It doesn't simplify, so our radius is the square root of 11. Let's try the next example. X minus 1/2 squared plus y minus 1/3 squared equals 9/25. The center, the coordinates for the center will always be the opposite of the signs that we see inside the parentheses. So I see minus 1/2 and minus 1/3. So our center will be positive 1/2 and positive 1/3. The radius is always the square root of the constant, since the constant in our standard form is r squared. So we take the square root of the constant, and then we try to simplify that radical, simplifying the square root of 9 over 25. We break that up into the square root of the numerator over the square root of the denominator. Those are both perfects. We get our radius to be 3/5. Our next example, we want to find the center and radius of the equation x plus 4 squared plus y squared equals 54. You'll notice with this example, there's no parenthesis around the y. We can force it if we like. We can rewrite this x plus 4 squared plus, this would be y minus 0 squared, since y minus 0 would be just y. And now we can clearly identify the center. We always take the opposite signs from our equation to the center. So that's a plus 4. So the x-coordinate of our center is going to be negative 4. And we have a minus 0. So that's going to be 0. Our center is negative 4, 0. To identify the radius, we always take the square root of the constant, square root of 54. Then we want to simplify our radical. We look for the largest perfect square that's a factor of 54. That's going to be 9. Goes in 6 times. Our radius is 3 square root of 6. Our last example, x squared plus y squared minus 8 equals 0. You'll notice a couple things about this example. First, There are no parentheses around where the x is or the y is. And also, we have a 0 on the right-hand side. This is not in standard form at this point. To get this into standard form, we're going to add 8 to both sides. This gives us x squared plus y squared equals 8. Now that we're in standard form, we can identify the center and the radius. Like the previous example, since there is not parentheses around the x with a number being raised to the second power, we know that the coordinates for both the x and y of the center are 0. If you really wanted to, you could write that intermediate step, x minus 0 squared plus y minus 0 squared equals 8. But we get the center to be the origin. To identify the radius, we simply take the square root of the constant. So the radius is the square root of 8. And we want to simplify the radical. We're looking for the largest perfect square that's a factor of 8. That would be 4. Goes in 2 times. We get our radius to be 2 square root of 2.